Galaxies look isolated. It's true they're trillions of kilometers apart, but they actually live in groups called clusters. And these clusters of galaxies are linked together in superclusters, containing tens of thousands of galaxies. So where does our Milky Way galaxy fit in?
If you take a look at the big picture, you realize that our galaxy is part of a local group of galaxies, perhaps 30, and our galaxy and Andromeda are the two biggest galaxies in this local group. But if you look even farther out, we are part of the Virgo supercluster of galaxies.
Scientists are now mapping the overall structure of the universe and the position of clusters and superclusters of galaxies. This is Apache Point Observatory in New Mexico, home to the Sloan Digital Sky Survey, or SDSS. It's a small telescope, but has a unique mission.
It's telling us about their shape, it's telling us about their makeup, it's telling us how they're distributed, and all of this is very important to astronomy in understanding our universe.
And this is what they're creating. The biggest 3D map ever. The map is showing us things we've never seen before. It shows galaxies in clusters and superclusters. But pull back even more, and we see that these superclusters are connected into structures called filaments. SDSS has found one that's 1.4 billion light-years across. It's called the Great Sloan Wall, and it's the largest single structure ever discovered in the history of science.
You get a sense of that you are in something quite vast. You could see the clusters and filaments as the data would scroll by. And you know, each one of these little fuzzy spots were actually galaxies, not stars, but galaxies. And so you're seeing whole clusters of these things.
SDSS is showing galactic geography on a huge scale. But scientists have taken it even further. They've built the whole universe in a supercomputer. Here you can't see individual galaxies. You can't even see galaxy clusters. What you can see are superclusters, linked together on filaments in a vast cosmic web.
As one begins to come back from the whole scale of the universe, one begins to reveal a filamentary pattern, a cosmic web of containing galaxies and clusters of galaxies that light up the universe, where there are as many galaxies in that direction as that direction as that direction and that direction. And in fact, on larger scales, the universe kind of looks like a sponge.
Each of the filaments is home to millions of galaxy clusters, all bound together by dark matter. In this computer simulation, the dark matter glows along the filaments.
Dark matter affects where in the universe galaxies will form. When we look at galaxies, they're not sprinkled around at random. They actually tend to form in little groups, and that's really reflecting the large-scale distribution of dark matter.
Dark matter holds together the whole superstructure of the universe. It binds galaxies in clusters and clusters in superclusters. All these are locked together in a web of filaments. Without dark matter, the whole structure of the universe would simply fall apart. This is the big picture of our universe. It's a giant cosmic web.